So this is, as I said, very much Hyperknowledge vision, but I'm trying to explain, and it means it will go explicitly beyond what individual knowledge applications will need. But I'm trying to explain how I see building from individual knowledge components onwards. And when I say individual knowledge components, I mean basically domain-specific application. What I think will happen very often is that we have a domain application which is specialized for a given either scientific or public or whatever domain, and has its own idea of how concepts should be arranged. And it has domain data, which is not necessarily conceptual. And it has concept data, but putting them separate is a bit of a misnomer because maybe the domain data is also concepts. What's important is that it needs to be exposed. There has to be an API point so you can ask, okay, what is the domain data? What is the concept data? And I assume that the domain application has its own way to show, of course, its domain data and probably its own local concept data, but that may not be true yet. Maybe the first step is to create the notion of concept data and views for that concept data within a given domain application. So that's kind of the starting. And can
you give an example of domain data and concept data?
We've been speaking about forges, for example, right? In a forge, domain data is a project, a change set to code, and for example, a branch that's purely domain data, but some of those branches are for the purpose of implementing a feature. Feature may be domain data, but it's getting closer to also being a concept. And certainly the feature is in terms of a use case. And the use case either is or contains concepts. The definition of the use case either is a concept, like I think a use case is a concept, and certainly it refers to concepts, like who is this useful for, what's the task definition, blah, blah, blah. Those are things that I think would exist, for example, and I expect those things to be definable in the MMM. But the notion of code review, for example, is very domain specific, and you may not want to model that in the MMM. Does that make sense?
Good. Can you say the last sentence you said? You may not what?
You may not want to model something such as a code change set in the MMM. It may not be a useful.
I don't understand what you mean by model in the MMM. No.
Is that, will you have an entity for the model change set? Will people talk about it, discuss about it in terms of the MMM concepts? I don't think so. It's a coding, it's an artifact of the coding process, which in this case is the domain coding.
Are you talking about the content of that you put inside, or of the structure in which you put the content? Because there will be inside whatever people want to put. So it will be in there, but I wouldn't say it's model. It would just say it's expressed. And the MMM, there is nothing else than what I showed you. So I don't make these kinds of distinctions.
What I'm trying to say is you're looking at getting people to use the MMM in their everyday, using tools they already know, hopefully, because you've been asked to insert it in existing processes. So what I'm saying is there's applications that already exist for whatever existing process. Here, in the case of the forge, the process is coding. And the coding has its own artifacts, its own concepts, which may or may not be put in correspondence with MMM concepts. I think, for example, a code change is not you will rarely want to talk about it in terms of the MMM links and relations. I may be wrong. That's almost a question to you. But I assume in general, it's possible that some things are too domain specific for the MMM. And you'll want to have the MMM discussion alongside that for another layer, another level, such as if you speak about use cases, it's useful to have the type of MMM discussion about, this use case, contests or nuances in other use cases. Does that make sense? So some concepts are squarely domain data, like code changes. Some examples are purely what I'm calling concept data, like basically all the MMM entities and links, and some are kind of in between and belong to both worlds. And that's what I'm trying to say. And all of those exist within the domain application, and the domain application will have its own way to represent like views on all this. And the first step, in a way, is to start to introduce a data model for the concepts, for example, MMM, and connecting it to the domain objects that already exist in whatever the application is, when appropriate. So that's kind of step 0. And then what I'm saying is, if you want to deal with multiple domain applications, you want to connect them. So the idea is that there's a kind of knowledge hub that takes the local concept data from many domain applications and combines it in a unified view, which is the community concept data. Knowledge hub belongs to a community, but it can take data from many applications. And there's a module that says, well, this local concept in this application and that local concept in this application correspond to this community concept. So that's the concept unification tool here, or module. It's basically a correspondence table. And then in the knowledge hub, you can have a contextualized view. What I mean by that is you're in the domain application, you're viewing something which has local concept data, and you want to know, how is this talked about in other applications? You would not go to the other applications, you'd have a link to the knowledge hub. That's, again, step 0. We want better than that, but build small building block. Like have a link in the domain application saying, look at the concepts of this view, because presumably a domain-specific view will have a bunch of concepts, and say, look at all the concepts in this view in the knowledge hub. So you'll see a contextualized view with more concepts from other applications that talk about the same concepts. So you will see how these concepts are connected or described in other domain applications. This unification, saying, this local concepts correspond to that local concept, it can be done by humans, it can be done by AI. And what's important is it's contestable, and we'll get back to that. You can say, yeah, I'm not sure about this unification, or I'm not sure about this distinction. You can justify, I don't want to unify this, and that's a distinction. And here's why, and how these concepts are different, despite looking alike to some people. So that's a data model right there. And what's important is, of course, you need a data model for the community concept data that's abstract enough to contain multiple different local concept data models. And then the next step after that is basically have a service that does concept identification. So basically, given a domain data object or even a description within a concept, you can say, oh, this text in the data domain, or this data structure in the data domain, or this text in the data domain, or a concept description contains these other sub-concepts. Why I think it's important, because it's a way to bring together concepts and look at what are the similar concepts and what are the components and what are we talking about. So basically have a service that says, I think this domain data object or this concept, local concept data object contains these other concepts, which may or may not be there, maybe in the community concept data, but that's kind of having a service there. And then to make that better for users, the next step would be, but this is, in a way, that's the minimum. We could stop there. But I think to make that better for users, you'd want transclusion. That is, you want both. Like I said, oh, you can have the local view in the application and then ask the Knowledge Hub, okay, show me how this fits in the larger picture of all the concepts from all the applications. Well, can we embed that view in certain domain applications? We don't have to do it for everybody, but for some key domain application, it may be worth it to be able to embed the broader view. And vice versa, in the Knowledge Hub, when we have a community concept, we can say, well, this came from that domain application. Here's how it looked like in the original domain application. So this is about view embeddings. It's not technically terribly difficult, but I think it would add usability. So that's one, and probably endless project, because each time you add a domain application, you have to add stuff, but we have a contextualized viewport building block in the Knowledge Hub. So that's something we'd offer. And among those, something that I think is really important is a view that says, well, here's a bit of text that can live in the domain application view, but here are the concepts identified within there. And each of those, you can look at everything that's connected to it according to all the applications. So that's something I think is important as a module. I had concept unification within the Knowledge Hub. Eventually, I think it should be detached as a service. So we could have concept unification distinction as an external service. Why is that? It's because it opens the door to federation. What does federation mean? This is far future. This is not within this scope, but I'm trying to give the why I want all this for Hyperknowledge. I want federated query. If you have multiple Knowledge Hubs, then I want to be able to say, oh, my Knowledge Hub knows about these applications. Somebody else's Knowledge Hub knows about those applications. Can I make a query and look at all anybody knows about these concepts? But that requires having negotiation of concept identifiers. And that's one step towards canonicalization in terms of the canonical debate. Which is, again, this is a much broader vision that I'm just going through while I'm here. But basically, when two hubs are aware of each other, they'll say, okay, how many of your how many hubs do you know that use this identifier for this community concept? How many hubs do you know? And have a kind of majority rule. So the Knowledge Hubs would adopt identifiers. It's not about adopting a concept and believing it's true. It's about adopting a common name for a concept. And that would kind of percolate and unify. It's not important what we unify to, as long as we unify, because this is what allows federated query, and this is what allows canonicalization. And then another federation layer is epistemic, socio-epistemic federation. So obviously, within a community corresponding to a Knowledge Hub, people have more or less the same idea in the community about the epistemic status of a statement. Like, is this a research question or is it provisional truth, for example? There's other possibilities, but we assume a community basically agrees on the status of this in its own way. But when you're doing a federation, you're trying to see, oh, this thing which this community takes as a provisional truth is contested elsewhere or is researched elsewhere. And so you'd want to have this kind of epistemic federation at the federation level. And the next step is unification reputation mechanisms. If we have concept unification between, at the federated level, sorry, I probably didn't make that identify. Yeah. It's not just agreeing on the identifier, on the common identifier. I said that was innocuous, but there's a non-innocuous part to that, which is saying, well, those two concepts are, we agree that they're the same, or we agree that they're not the same. That is not innocuous, and that means we'll need a reputation layer for that. Now, this is not about you're right or you're good, but you make useful distinction. You make sensible distinctions. And so that's a very limited notion of reputation, which is probably easier to detach from epistemic reputation, which would be another layer. So this is, oh, and the last component in terms of what we have to build is a kind of subscription pub-sub mechanism for all of this, so that when something changes in the domain application, the Knowledge Hub becomes aware of it. The Federation subscribes to the Knowledge Hub, so it becomes aware of the change. So there's percolation up, and the Knowledge Hubs are kind of, they're being subscribed to by the domain application and by the Federation. So they're the kind of transmission system for changes in any of those systems. And so what I'm trying to do is to distinguish short-term, mid-term, long-term goals. So short-term, there would be domain-specific concept UX, which can be very domain-specific. And then an abstract concept model, which can be put in the K-Hub so it can unify more than one knowledge model. And then what's very important is to have a contestable concept unification model. Not terribly difficult, but it has to be done. And then you can build this view within the K-Hub of here is how these local concepts fit in the community across many applications. And then you can have a basic UX for saying, is this the same idea as that or not? And is that related or not? Is there a distinction here or not? The first one. And then the domain application has to link to the K-Hub. That's the minimum. You have a useful system there. That's the minimal viable product as such. To make it better, I said, like I'm recapping here. There's nothing new in these slides. Identify concept, the concept identification, identify concept within domain objects, local epistemic status, transclusion, like putting the global view in the application domain and vice versa. Improve the local map for community embedding. We have basically, we already knew that the domain app would have to say, here are my local concepts and how they are connected to the domain objects. But what you want to say then is improve it to say, well, and by the way, there's this stuff from the Knowledge Hub from other applications. So improve the local map to include that, improve the unification user experience, experiment probably with automatic natural language processing unification, again, with a verification layer with humans, with validation. And again, you have another, I think, layer of functionality there, but it can be done in the longer run and incremental improvements. And the long-term Hyperknowledge vision is federated queries between K-Hubs, global concept identifier by contagion, the canonicalization using those global concept identifiers, and that's the canonical debate vision. Epistemic federation, what does it mean to combine the community epistemic status, the reputation for unification and reputation for epistemic. But that's not necessary for a functional system, but that's the long-term Hyperknowledge vision. So those are my component diagrams, questions. I think somebody joined late. The slides are, I'll put them in the Slack. Do you see, should we, anything before we go into MMM details? Anybody
Could you
thinks
show us could I just look at your the most complete slide for a while? So it was very fast for me, and
I went fast, yes.
Very, could you, it's going to be repetition, but would you mind?
I don't mind.
Going through slowly, just talking slowly, not necessarily saying that much. So it's just, it has
No,
time.
no, I understand. Reinforce.
Yeah.
And after that, I'll ask, what do you think I forgot? But that's something else. Okay, so we start with the domain application, which has domain data, and we're slowly adding to it the notion that, well, some of those domain objects may actually be concepts or may be related to concepts. Yes.
Can I give an example so that,
yes,
to illustrate?
Let's keep this public.
Sorry?
Let's keep this public. So at this point.
Yeah, but I'm thinking of a paper I've read recently where they were say you want to make a robot that serves coffee or that wants to cook. It's making pasta. It knows how to do this. You've entered the recipe and it needs to know how to put more salt in it, but there is no salt available in the kitchen, and it needs, so there are a number of concepts that are not dependent on the situation on this particular kitchen where there is no salt. Like the term salt is something that exists beyond the kitchen. So I suppose this is not a concept, right? It's so the fact that there is in this kitchen there is no salt. This is something very specific to the situation. So it's not typically, that wouldn't go in the MMM, I think. The fact that there is salt and that salt is good in pasta would go in the MMM.
I got it.
Yeah.
Right. For me, whether you want to make that fact public or not is a choice. And I understand perfectly why you could want to make it public or not.
Which fact exactly?
The situation specific fact that this kitchen has no salt.
Let's say we don't want to make it public, right? Because it would
That's
be
a choice. That's a
one
domain application
robot
choice.
that is in somebody's kitchen, and the world doesn't need to know whether there's salt.
I agree. It doesn't, and that's exactly what I mean by choice. It's the domain application decides what it publishes. I certainly think that such a thing is a claim and it's expressible as a concept if you choose to, and it's absolutely reasonable to decide this is not public information and I don't want to publish it and I don't want to make it a concept. Either is fine. For me, this is...
Concept is synonym to public?
Nope. Oh, good point. It's not, but you're right. I'm kind of conflating two things here. Very, very good catch. But here, from the point of view of this system, yes, but you're absolutely right. There will be private concepts within the domain application. The thing, when I say the distinction, and as I said, it's not a hard distinction between domain data and local concept data, is from the point of view of we're trying to evolve a domain application, we're trying to evolve a pre-existing domain application to become concept aware or aware of the notion that it could share concept with other applications. So there's already this domain application with all its domain data that exists. And some of those domain data objects, as I said, naturally could translate to public concepts. Some could naturally translate to private concepts, and some won't translate to concepts. And that's a choice. And,
so, yes,
and in some cases, there's concepts that do not correspond to domain data objects yet and will be expressed just as concepts. And that's, again, some of these may be public, some of these may be private. But what I'm saying is, this is the point of view. You have a domain data application which knows about data, domain data, whatever that is, and then we're trying to augment it and add the notion, hey, you'll be sharing concepts soon. Do you have, what part of your data corresponds to concepts? Or does it need to be added because you don't have it yet? Like in your case, I understand you're working with a forge in the most general terms. So not everything in the forge belongs in the concept, according to you, and I agree. And you want people to start using concepts and links between concepts while they're doing whatever they're doing in the forge. So that means you'll add data structures for concepts to the forge first. And that means adding views to the forge, perhaps. But the point is, there is something you want to, of the domain operations and domain, domain use cases and domain data objects that you want to, people to have a MMM structured discussion about. And that means exposing those things to a concept-aware machinery.
So we're talking about how we take content produced somewhere and acquiring, just this step for now, right?
Yeah. Either
and
that.
If I take the example again of the robots, the concepts would be that you would like maybe to share if like people who created the robotic ontology and fed it to the robot who's going to serve you coffee or make pizza, they would provide the ontology. The typical concept you would use would be those that are in the ontology, those that are making the robot work. Like salt is better, a certain amount of salt is good for pizza. And maybe
I'd like to continue with the software forge idea, because I think it's a good, rich, and it's generic enough. If you're okay with that.
Okay, but yeah, okay. I have less intuition on this because the levels of abstraction are more difficult to follow, I feel.
Okay.
See, because if you're talking of salt, you know, you're not talking of a system.
Okay.
But maybe you can use a bit of.
Well, okay. Let's take the robot thing. Fair enough. The recipe and the recipe ingredients are all something that the robot system could like to have discussed, because people would like to compare recipes. That means they probably need to expose the notion of recipe and the notion of recipe ingredient. They could say that the way this specific robot executes recipes is not relevant to the global conversation. For example, that's a choice, and it's a legitimate choice. Or they'll want to expose it because there's limitations to which recipes can be made because of the robot's limitations. So they may want to expose, these are the steps I could do, and those are the steps I could not do as this particular robot built. Right? Do they want to expose this or not? But what I'm saying is the robot application already has all these concepts in its inner database and its inner software. And then it's saying, well, I want to participate in discussions about just recipes. So I'll expose recipes and ingredients, or recipes I could do given my limitations. And then I'll expose a bit more about the list of types of recipe steps I can do. But that's a choice. You may or may not expose that part. You may decide the types of steps I can do and how I do that is purely domain data, or you could make it a concept data. But you're starting with a database that has all of this as domain data, and you're saying, well, this table, the ingredients, and this table, the recipe, those I will expose as concepts. And then there's something else that I didn't have about, which is the notion of improving a recipe. That was not known to the robot first. It just had recipes and followed them. Now you're speaking about improving recipes. So that means you're augmenting the robot software with the notion of if this recipe an improvement on that one, or adjusting a recipe, like what's a substitution when an ingredient isn't available. So that's another possible relationship between recipes. And so you need to add tables in the robot database to say, this is what I'm doing now. I'm now speaking about relationship between recipes, improvements, substitutions, and the like. And those were the substitutions would be relationship between ingredients. When can I substitute basil for oregano or not, right? When does it make sense, and type affinities and whatever. So these are new things that you're augmenting the robot software with, because you want it to be part of a conversation. And then once you've added new concept data and added and exposed part of your domain data as concept data, this gets, it's exposed. That means it's consumed by the Knowledge Hub as, okay, here's the community concept data. And how does it do that? Well, it needs the concept unification, saying, oh, the courgette ingredient in this database corresponds to the zucchini ingredient in that other database, right? Because those are just two names for the same thing. And there's two recipes that happen to be, yeah.
How is this done, the unification?
as I said, it can be humans, it can be NLP, it can be, you know, as stupid as it's the same text, or natural language embedding. The point is, I don't care. What is important is that I'll start with humans because it's easier, or identical string because it's easy, though it's not reliable. What is important is that it can be contested. And so in the unification distinction table, you can say, oh, courgette is zucchini, and zucchini mean the same thing in general, but it so happened that in this region, when they say courgette, they actually mean another kind of squash. And so it's not...
And who does that? Who does that? Who looks at these tables and goes through, okay, zucchini, courgette, salt, bicarbonate, I don't know, and goes through it, and then whose job is it to do that?
That I see as crowdsourced, humans. But as I said, NLP can help, can give us a starting point, but it would be seen as NLP unreliable until checked by a human. And that's what happens when you have people develop domain applications independently. They do their local concept data independently. Now, some of them, you'll tell them, hey, use the MMM concept types, which helps already because you have a common ontology. It doesn't mean that they'll use the same concept names, which is something else. But at least it's one layer of similarity, but somebody else will independently develop something else, and it would be good to get them in. So this is one you want, concept unification as a service, and as a service that can evolve independently. So the Knowledge Hub will rely on concept unification services to create this, well, this is all I know from all those domain applications in this community, because Knowledge Hub, again, corresponds to a community. And then you can create this view of, well, this is what I know from all the applications in my community, so that when you're in the domain application, you're looking at the local view. Here's the little recipe box. There's a link saying, oh, by the way, this recipe, look at it in the community view, and you see that somebody else elsewhere has proposed an improvement to it in another application. Or somebody else elsewhere says, hey, there's a health hazard on this one, or, you know, because it's totally a different application domain, it's health hazards, but you still want to know that this ingredient has been recalled because of a salmonella outbreak, you know, whatever. The point is it's application specific, but you want to be able to link from the local view in your recipe application, click a link, say, okay, what does the whole Knowledge Hub have about this? And then you'll see, hey, guess what? I shouldn't use that ham. Yep.
So I understand that there are different domain applications. This is just, you get the data from different places.
Yeah.
Right. I'm trying to understand, why do you have different knowledge hubs? This is so that you can have people who look at things in the same way.
The idea is, okay, I'm speaking about unifying. So people will unify. And I'm saying just I expect different communities will do. We're not the only ones thinking about this. Somebody else will create another way of unifying data. I can name 5 projects who try to do data unification, right? So we're creating a knowledge hub. Somebody else will create another knowledge hub. And yes, I think knowledge hubs will align with communities because it is simpler for the knowledge hub to work if higher order concepts, such as claims, this recipe is actually an improvement of this one, and it's not worse, are kind of shared by the community, because then you don't have to deal with social truth. You're just dealing with this community as a whole believes this. Think of research, or think of science research. In this scientific community, we're dealing with ballistics. We're fine with Newtonian gravity because our domain is ballistics, and that's one K-hub. And another community is doing at astronomy, And well, at some point, Newtonian gravity was a contested hypothesis, and now it's just thrown out of the window. That's fine. It's something else. It's another K-hub, it's another domain. But within the community, it's either contested, in question, like this is the research, this is what we're researching right now. Is this new theory of gravity new, say Einsteinian gravity, or is this established truth we're building on, or provisionally established truth we're building on? We're taking Newtonian gravity for granted.
So you're relying on communities that already exist there. So you have, or more or less, or who already have some incentive to all say, okay, guys, we all are working more or less on the same thing. So it would be useful that we federate. Well, we have something in common, so that we would be more efficient. So a part that is important is that the world is made of communities already, and we rely on those.
I'm assuming that, yes, I'm assuming communities exist, or they will form, right? I mean,
I have another example then of a community of just simply working groups, like the one I was referring to the other day, where they formed. It's a very small community of, I don't know, 30 people, academics, people from the industry, and politicians who have to define a term like digital twin, thing like this, and they create a workshop just for that. And so in that moment creates a community, and the aim is to find a common jargon in a word.
That's perfectly, that's a very, it's a bit smaller than what I'm trying to aim at for community, because it's very goal directed and it will dissolve after that, but it's possible that such a community would build a K-hub.
And is that a problem if it dissolves? What remains?
Well, it's true. It's a problem in that they may shut the K-hub at some point. And this is why I might think about either distributed web or some other way to do knowledge archival of a knowledge hub, because the next step is saying, let's take all these little sub-communities and do federated queries. Now, if a knowledge hub shuts down, which is a perfectly realistic scenario, we'll want an archive so that the federation still has access to whatever was published by that knowledge hub. So that is not shown, so that is maybe something we'll have to think. I'll add to the long-term list, our knowledge hub archival as a process. But let's not think about this now. This is much longer term. But the point is, between teams, the idea is, if I'm saying, oh, what do we have on this concept? Well, ask the federation, and the federation will ask all these federated query, all these other knowledge hubs it's aware of. What do you know about this? What do you know about this? What do you know about this? And there are ways to make that relatively efficient.
It's something quite important from the start, because in science, there aren't really communities that you want to last. You want them to get destroyed and to evolve, and you want the jargon, the words, the terminologies to change very fast. And I have the example in my domain where the community, there was one review that was made in 2001 of the community, and it was very complete and very high quality, and it's the biggest pain in my ass. For all the time I was doing research, my little sub community was really hindered by this, because they had become so accustomed to using the same kind of terms that it fixed their points of view, and nobody could see it any other way. And because us as a little group, we were so much in this bigger group, and we were not big enough and not old enough to really dissociate and defend our own view. It was super difficult. It was one of the biggest obstacles I had in research. It was to say, no, guys, even though this is the mainstream view, it's not the only view.
I agree totally with what you're saying, but two buts here. One is, I think it's very important to have a terminology evolution within a hub. Like within a hub, you may say, okay, this was the term now, that's the term now. So, and here you're speaking about fractal subcommunity, which diverges. And yeah, you could have a different hub for that, makes perfect sense. And yes, I agree, for that you need evolution, but you could also do it. I'm also thinking about ways to do sub-communities within a hub. But I'm not getting into that in this level of diagram because the diagram would become impossible to read, but that's something I'm considering. And so I'm thinking of community as slightly larger and more long-lasting than you're thinking. You're thinking on the scale of research project. I'm thinking on the scale of a research community.
No, a research community. I'm thinking of the research community that I know that started in the 40s and of every step of the way.
Okay, fair enough.
So I'm thinking like 30 years, but in these 30 years, from my experience, some things could have been done like in the first 2 years of after a certain step, but they waited 30 years to do it. And I know why they waited, and it really could have been avoided if there hadn't been some common grounds, actually. If the common grounds hadn't been so well
entrenched.
Yeah.
No, I understand. It makes sense to me. And this is why it must be very easy, either within a knowledge hub or as a different knowledge hub, either is fine, to spin off a subspace where we're saying, okay, here are the assumptions in this subspace. Like I'm adequating knowledge hub with knowledge domain in this diagram because I'm simplifying. But yes, for me, a knowledge hub can have many knowledge domain, and each knowledge domain has the epistemic is unified more within the knowledge domain than the knowledge hub. I was simplifying here, but it should be easy to spin off a knowledge subdomain within a hub, where you could say, no, this is what we believe in this subgroup of this community, and let's see where we go with that.
But that would mean that we would need to, in some cases, like the only link between the subcommunity and the community would be a very non-epistemic. It would be more like, in my case, it was like just the mass model, and the fact that we were looking at questions that were very fundamental. So there was a certain methodology in common, but all the interpretation and all the really deep ways of thinking about what we were doing was completely different. Even the term model was completely different from my closest colleagues and me. There was like as much a difference you can have in between any two places of science, and this came like from inside.
That's a bit of research. One of the parts where I'm very struggling a bit. What is the relationship between a subgroup and its enclosing group? Do we consider it as totally independent, which is possible, but it means we need, like often there will be a common basis, right? There are statements that are believed by both. There are statements where you diverge. And so do I want to treat it as a branch, saying we believe all of it that is common, except this is where we differ, which is one possibility? Or do I want to say, oh, let's restart from scratch and say, you know, this, and what we believe in common, like specify what's common and build from there, or specify what's different.
The difficulty is that there's as many in every individual. When you reach a certain point, every individual is an instance of it represents one kind of thinking, and I myself was represented my own way of thinking, which was super different from, a little bit less different from a bit further away in the community, but we can represent so much different things that dividing things in between what is different and what is similar is very difficult, because it really depends even the kind of thing we are thinking about, and the approach, because the words matter so little in some cases that we are very used to just saying, okay, I'll just use the same word as you because this is not what we're working on, so never mind. Today in this work group, I'll use the word automata the same. I'll pretend that I'm using it the same way, and we're constantly pretending. So, and it works. That's how we make it work. And sometimes we pretend so much it becomes uncomfortable. So you say, no, I'm fed up. I want to say I'm not part of this community because all I do is just use the same math model.
No. Mathilde, this is exactly the kinds of concerns I'm interested in with hyperknowledge. It's the whole, how do we make the distinctions explicit? How can we say, okay, in this case, a distinction doesn't matter. We're using a common abstraction. In this case, a distinction matters. And we want to say which one of those two competing definitions I mean.
But you want to decide this. What I'm not sure I understand is, for me is something that cannot be anything other than organic and decided on a case-by-case basis by
absolutely
people.
ad hoc, so, ad hoc on the fly.
Okay.
Has to be ad hoc on the fly.
And okay, so what part is missing then? If we agree on the fact that this is going to be taken care of by people who are dealing with the content themselves, what part do we need to figure out? Do you need to figure out in advance?
The basic, I almost want to say it's an optimization concern in the sense that, and not so much computer optimization because that doesn't matter, but the human optimization. When do you bother the user with asking, okay, which way do you mean this? Or are you sure you didn't start using it this other way? Or are you sure you mean this one and not this one? So there's a very delicate UX balance. And there's all kind of modeling things underneath that make the UX make sense that I care about. But the real question is, when do you bother the user and how?
From my experience, that's exactly what I've been doing for a big part of the last years. And my answer to this is almost never, ever, ever. Because even when you're one human being, like that was my role when I was doing research. I was among people who were especially like more experimental scientists, and they have their own agenda. And I was playing the role of the idiot all the time, saying, I don't understand. Why do you do that? And because I come from a very formal science, very, every time they said something that wasn't perfectly in line with the model, I would be the one like saying, I don't know any biology, so I don't understand this. I just understand that it's not in the model. And all my work came out of this. But the thing is, I was already a lot to handle, and I annoyed a lot of people. And I think it's okay for one person to do it a little bit, but they can't have somebody like me or a system on their back all the time. They can see somebody like me every once in a few months, and that's enough, because we don't necessarily need that much more, because after you've done that, you actually need to go and do some work with it. You have to actually follow through with it, and that takes a huge amount of work. And these people are already busy doing what they need to do, and making this automatic would there's a delicate balance in science that is, I don't think we can't predict in advance. That's the thing about science. It's so delicate. Every time has its own science, and science is always different from one period to the next.
I hear you that you don't want to hinder people going on their normal research program in perfectly Kuhnian terms. On the other hand, what for me an explicit goal, like I've seen, on the other hand, I've seen projects flounder because, false consensus, we thought we're saying the same thing, we didn't define the terms, and then we realized we're not aligned at all. So sometimes a question needs to be asked. And I think for me, an explicit goal is to be able to record those questions and to say, this distinction exists, and maybe it needs, and so if you're just doing your normal thing, you go on, and then at some point, hey, and this is where AI could be useful, actually. Hey, it looks like maybe you're not using, everything you said made me think you were using it this way, but here you're using it in a way that's more reminiscent of this one. Somebody proposed this distinction. Is this a relevant distinction? Does it matter? Could it make a difference? And so And then the beauty is it gets crowdsourced. Like somebody answers and says, no, in this case, it doesn't matter. In this case, it matters. And then it becomes, instead of, being one pair of humans getting on one another's nerves, like somebody resolves it, and then it becomes resolved for a lot of people. So that is totally in agenda for me, to find ways to crowdsource this resolution works so that we can find a better balance on this.
I believe that. That makes sense.
Good. So where were we? So I think we're a bit clearer on what's in Knowledge Hub, and it's true I was playing fast and loose with knowledge subdomains, and I didn't go in that because, again, I'm trying to see what's the minimum viable product that we can build quickly, and a lot of the nuances about subcommunities and stuff can be added later. At first, we can have one Knowledge Hub per subcommunity. It works. We have a solution that works.
So prepare yourself for me to be always holding back on this notion, because I'm very scared by communities. They've been a big part of who I am today, and
But again, okay, we'll discuss. But again, the idea of the Knowledge Hub can be at any layer. It can be research community or research group. It doesn't matter, because the resolution will be done at the federation level. And this is where you're saying there's this negotiation about concept identification, negotiation about concept unification, and then people will gain reputation. Here I'm a bit, this is a total hand waving. I don't know how I would have a reputation for somebody or some process who does good or bad concept unification or concept distinctions, but still, I think it's possible to say, hey, your distinctions are always perfectly spurious and useless. Hey, you unified things that did not belong together. I think it should be easy to have a negative reputation. Positive is more complicated.
Marc-Antoine?
Oui.
Sorry, what is the difference between everything that is in the cloud, in the federation part, and concept unification? Concept unification isn't part of, you said it was crowdsourced also, no? It could be crowdsourced.
Yes. Okay.
What is the difference between something that is crowdsourced and something that comes from federation?
It's more about this other diagram about, this is kind of within a domain application. Multiple domain applications are shared by a knowledge hub, and the federation combines knowledge hubs. So here you need concept unification at this layer to unify many applications in a knowledge hub. And you need another layer of unification to unify multiple knowledge hubs together. But this one assumes more or less, because it's for one knowledge hub, this assumes a more, like, it should be easier to make the community agree on, hey, this is just different applications, but we know what we're talking about. Here, it's like there can be a lot of arguments about, is this the same thing or not? And federated queries, so you can ask, even at this level, what else do we know about this local concept? As the knowledge hub, ask the federation, and the federation will say, well, within your community, this is what else is said, but within the whole federation, slower query, here are new contestations from totally different communities, or contestations or improvements or whatever it is, better recipes, doesn't matter. This is the federated query layer, but for that requires knowing that a zucchini and a courgette are the same thing. And this requires making sure that you don't confuse the courgette with some other squash, which is used spuriously synonymous in the subcommunity. So this is where there's negotiation layer and reputation. Are you introducing this information at the concept identity level, which is different than the epistemic reputation. You're just saying lies, which I didn't put in the diagram.
So there's a difference of who you crowdsource this to, or how big is the community who takes care of the federations relative to the services is still, you're within a community, but you could imagine you still, some of the mechanisms you use could be in common for both, but they're just not applied.
I could see many knowledge hubs of many communities using the same service, right? But here, because it's, for example, the concept identification, there's somebody creates an NLP thing that can identify entities in text. Now, the services here, I'll have to adapt to this knowledge hub, because here are the local concept identifier that, this knowledge hub uses DBpedia identifiers, and this other knowledge hub uses Wikidata identifiers. So the service will have to adapt a bit, but there's probably a bunch of people using either DBpedia or Wikidata, so it can be shared by a lot of knowledge hubs. And the same with concept unification distinction. I'm good at holding a table of equivalences, and I can hold many tables for many knowledge hubs, but I've created this service about defining unification and distinctions. But probably this concept unification distinction, in a way, it exists at knowledge hub and federation level, but I took it away in service to show that reputation at some point will apply to a concept unification source, whether or not it corresponds to a knowledge hub. Sometimes it will be an NLP system that will say, I think those are the same because knowledge embedding. How accurate is that NLP? That's the job of unification reputation. And it's important for any knowledge hub to know that, well, this NLP is not that accurate, right? But it's a useful service because it gives you a zero human work solution for a first approximation. And it's shared by many knowledge hubs that way. So that's why I'm putting it as a service. It's not a federation service, as it's not inter-knowledge hub. It's between the knowledge hub that we learn, hey, we don't trust this one, or
so it's still domain specific. So
it could be or not, but yeah.
But it's linked to a domain to a series of domain applications. Right?
Yeah, it has to be aware to. Yeah, well,
there has to be something in common.
Yeah, I see concept unification, very specific services that know about the shape of this particular domain data and how and where to extract concept ideas from there, right? And so federated queries, identifier negotiation, unification reputation, and epistemic federation, is saying, in this community, this is a ground truth, and in that community, it's contested. So we want to know that this concept is, usually accepted, but sometimes contested, and things like that. And is the contestation fringe? Is it itself disbelieved by people we consider reputable, or using a proper methodology, and so on? And that's the difficult part of epistemic federation.
Actually, right now we see I'm going to contradict myself, because I was my instinct is to be afraid of communities and to want to defend the free spirit who's going to break down every principle on which is built the community. But I see in what you say some interest in having communities, because in knowing where are the communities, because it can direct your efforts on saying, like, these are the questions, the differences between the epistemics of two communities, and that might be, you might be quicker at if you want to make some change at focusing on in the in-betweens.
Exactly. That is totally the value of that. Okay, I think, anybody see anything I missed before we close that section?
Well, there's only 2 of us left, so.
Oh well. Michael?
No, it's good. I'm still just tracking as best I can, and it's good so far.
Okay, good. So there's a lot of specifics about what's needed at each layer and yada yada, but then we get into specifics. And what I wanted was to have this distinction between, okay, what basically this was about writing the work items, so to speak, short-term, mid-term, long-term, but ideally you will have something to propose, MVP just from the short-term things. The mid-term can be continuous improvement of that, and the long-term will be my long-term dream.
Can you show the short term a little bit?
Mm-hmm.
Abstract concept model. Can you say?
Yes. Because I want to be able. Okay, first, some applications will have. Well, I expect many applications to have their own concept model. First, from their domain objects, and second, some of them will decide to implement, to add to their domain layer concepts using the MMM model or a CDL derived model or something, RDF ontologies or whatever it is they choose to use. I want to be able to capture any of those in the knowledge hub. So the idea is that it's possible to translate domain-specific concepts to something more abstract than the knowledge hub, so it's easier to combine things. Like I gave the example of recipe and secure salmonella outbreak advisory. They are totally different things, and to make them coexist requires certainly layer of abstraction.
So in this part, so on one side you have ontologies, which are pre or up, even upper ontologies, which all of which take a certain point of view on reality. It's in the name ontology, what exists, what matters to us. And on the other side, there's the MMM, which takes no such thing and just says, here's some pretty blank space, just filling the gaps, and you're very free to fill in the gaps more or less however you want, and you can like be redundant, you can say silly things where you can say something exists and you can say it doesn't exist, you can contradict yourself, and you can say you can just not talk about things that exist anyway, you can just ask questions and not state anything. And where does this number 2 list, this abstract concept model fit in this?
It's closer to the, okay, for me, the MMM has quote unquote ontological commitments. You know, it has categories and stuff about, for example, link types. I want to be agnostic about this. So it's more a very abstract data model so that I can say anything that any of the above can say. I'm not asking to be able to map them to the same data model, to be consistent, to check consistency. That is not a requirement at this level. What I want to know is that I'm able to capture this in the data model.
So why wouldn't it be like just using the default relationships and default node of the MMM?
Because the MMM has commitments. I want to be able to, okay, can you, it has link types, that's a commitment. It has node types, that's a commitment. I want to make zero commitment at the abstract model.
But does a link says something is linked to another? Yeah,
that's okay. The
so
nature,
the MMM has this. It has a node, which is default node, which is any type of content, and whether it be text or video, whether it be the story of your holidays or a recipe or some hardcore mathematics. So you have a place where you can put in content, and you can use links just like hyperlinks if you want that. So completely meaningless that are just pathways.
And in a way, that's close to what I'm doing with topic maps. Topic maps is just the blank part of the MMM. And then we can say, okay, if it comes from the MMM, well, here are the link types of the MMM, and here are the node types of the MMM, and those become a specialization of the abstract topic map model for the MMM ontology. And then another one will be using all ontologies and will have a specialization of topic maps for all ontologies. And the idea is to have a common model that allows me to express either.
In what direction would it, you said the topic map would specialize for different ontologies, right?
Yeah, and for me, the non-blank part of the MMM is an ontology, in a way.
Well,
it's a free form ontology, but it's an ontology in the sense that here are the link types, here are the node types. That's an ontology at the minimal level. You know, it's a typology, if you will, maybe not an ontology.
I don't agree with the ontology. It creates too much
okay, ontology has too much baggage.
Ontology means something exists, and when you say
okay, let's call it a typology.
What?
Typology.
Typology.
Or maybe something even looser than a typology. I don't care.
I think even looser, because, yeah, typology would be better, but since a type can be interpreted in very different ways, and you can put, like I explained, that the link translate can convey such different types of information that it's almost like a bit of an abuse to say that would be a type. It was sort of not the idea we wanted to put in type.
How about even classification has too much baggage? Labels. It has a set of labels. It has names for things.
Generally, the MMM is like just to guide you slightly, like to push you, but you can use things by default, but then it just adds a little bit to push you. If you can specify a little bit, just do it, but you don't have to.
And that's your choice, and I respect it, but I want to build something that respects all possible choices. People who want to be as loose as you are, people who want to be more strict. For me, they're all valid.
So, but you're talking, when you say people who want to be, you're not talking about people who are going to put content into, because in this case, the MMM allows anybody to be as loose as they want, and but maybe not as strict as they want.
Exactly.
At least as they want. Okay, so it's.
I want to allow either. Like if people want to make a note.
But I mean, the MMM, I can put my mathematics in it, so I can be as formal as it gets in it. But I won't be using. I'll just be using a default node, so it won't be very different from using an article.
What I'm saying is that is true, but it's also true. Like, okay. If I decide I want to do theorem proof checking with Coq, it's entirely possible to translate the Coq relations to MMM relations. It's entirely possible to go through MMM to then put it in Coq, but that's an useless extra step in that case, because I can just enter Coq directly and say, oh, by the way, these Coq relations correspond to MMM, and I have a translation layer. If my job is already to do Coq, which is a case, which is a real case of real people, then I wouldn't want to use the MMM. It's entirely possible that someone will want to think in a less formal way than Coq, and it's a valid case, and will want to use something less formal like the MMM. But if my job is to do Coq, why would I go through first say this is MMM, and by the way, it's also this Coq relation? That's absurd.
And the MMM is not made for that. Coq already exists, and
exactly.
I don't think the MMM would work for the.
Exactly, but I want the K-hub to be able to contain, not interpret even, but contain the data that was input in MMM format or in Coq format or in UML format or in OL format. I don't care. I want it to be contained in the K-hub. I'm not even talking about interpreting it or checking consistency or any of that, not at that layer. This is a high-level project, but containing it is not a high-level project. That's very easily done with topic maps.
Okay, for another session, I think I need to go through your diagrams again with Coq in mind.
Okay.
Because I think now, but I'm not sure I understand what is contained, because I was not thinking of. I was thinking more on the concepts.
Yeah.
The concept and Coq is something quite different. It's a different category. So, yeah.
Yeah, I'm being a bit, well, I'm
But I
trying to
suppose-
expand the,
But I suppose you understand why, you know why I'm a little bit surprised by the cock example, no?
of course,
Sorry. Okay.
of course. But I was giving cock as an extreme example, but the key point is cock already exists. And this is really what I want to say. All these domain applications already exist and people are entering stuff in them. And that means I'll want to take that data and capture it in the community concept data, so that if you put something in MMM, as I'm using this equation in MMM, as you just said, it would be nice for you to know, oh, by the way, somebody used this equation in a cock proof. So that one happens to be formally proved by cock. That's something you'd want to know. So I want to be able to say, this equation that came from the cock prover is the same as this thing you just entered as a LaTeX expression in the text of your MMM entry. That's what I mean by concept unification. And so you would have, oh, by the way, this thing I entered as an MMM entry, it's also been found in this cock proof, which is another domain application. You're muted.
I think this is too far in the future.
No, that's
not in a bad way. It's just that for me, like imagining that you first, when you write some math, that it means that you've been, if you want to have, know that it's been proven, I would think that maybe you would be right now you would be entering the equation as part of your draft. Because if you're writing a paper, the chances are you've already proven it and you don't need cock at this point. So it would be while you're thinking about things and putting things together. So instead of doing on paper, you would put it on, you would test it.
I've seen many math papers saying we want to prove C. We don't know how to prove C from axioms, but we know how to prove it from B, and we suspect B is true, though we don't have the proof for it yet. I've seen many math papers of that form.
But then they would just go use cock.
No, well, maybe they would use cock and say, oh, there's a link from B to C, not from axioms. And somebody else someday proves B, and look, the person who's working on C is like, hey, now C is proven because somebody else proved B. So that's one possibility. Or the person who just proved B says, oh, and by the way, I didn't know that this could be used to prove C. Yay.
Okay.
Okay, so that's what I mean by abstract concept model. Again, containing, just being able to take the cock proof and put it in the database, not even understanding it, and putting the LaTeX thing from your MMM thing and put it in the database. That's all I'm asking for. Now, unification becomes more, as I said, it becomes more complicated. And this is why you have many services saying, oh, by the way, can I transfer? You'd have a specialized service interpreting LaTeX expression as, is there an equivalent in a cock proof, for example? For example, that would be a specialized service. And there could be many services for concept unification. Or it could be, as I said, human crowdsourced. So you'll have both. But what is important is that this can often be transitive. If you write it in LaTeX, somebody else writes it in cock, somebody else writes it in, I don't know, what was the system everybody was using for a while for proofs, Mathematica, or whatever other system, then okay, you will find it across systems. That's the whole point, being able to say this is the same as that across systems, so that you're connecting the domain-specific applications. And then, as I said, create this view first in the K-hub, because that's simplest, saying, well, this is what we know around this concept, and from many applications. and being able to link from the domain application, linking to, okay, here's my local concept. What else do you know about it? Has it been connected to it? Has it been connected to anything from another application? If so, show me. And if not, well, can I start actually looking, and this is where NLP is useful, for similar stuff that's already in the common database and say, oh, is there anything I could connect it to? And that's what I mean by basic unification UX. Okay, yes.
Sorry, the semantics comes in step 3.
Yes, the unification, this is just the same as link, yeah.
So this is really what gives the semantics, because before that you just had content.
That's what expresses the semantics. What gives the semantics is step 6, humans and or with the help of NLP saying, yeah, I think this is the same as that. Three is just a little model to say, this is the same as that, but it has an identity and a provenance. I know it's this person or this NLP process who said this. And I can say, well, this is why I think those are not really the same. Here's the distinction that was missing. Next time somebody comes, somebody can say, oh, well, this distinction is not useful in my case, so I'll use the common abstraction. Or yes, this distinction is important in my case. So yeah, I mean this one and not this one. So just a model to be able to express that identity distinction.
To sum up, 3 expresses semantics that already has been produced beforehand.
3 expresses semantics that will be produced in step 6. The semantic of sameness of ideas between coming from different domain-specific apps.
I don't understand how you can express something that hasn't been produced already.
It's called defining a data format before you do the processes that fill in the database. Defining the database table before I fill it. No? What's it?
So you're defining, the framework, but you're not expressing the semantics. You're not expressing X before you produce.
Yeah, this is about defining the framework to express those things. That's exactly what I mean in this step. No more, no less. And then get people, and with or without the help of machine learning, to start saying, oh, I've just entered this. I see nothing connected yet. What could be connectable maybe just by word search or whatever, and then I'll make a few connections because it's useful to me to see, for me to see more connections. And then, as I said, link from the domain application to that view and augment the view with the basic. So that's short term. This is not a huge project. It's not an insane project. And I think it's already useful. And then you augment it by automatic identification of concept with human checking, local epistemic status for later, saying, is this something we as a community believe is provisionally true, or is it something we're researching, or provisionally false? Evidence and so on. Why do we believe it, if so? Transclusion, so that it's easier in the domain app to see the global view, and easier in the global view to see how did it look like in the domain app. Again, this can be done one piece at a time. And that also means being able to augment the text view on any description to say, oh, this text view is a concept, but it also contains other concepts in the text. And you can look around those. Improve the local map. So if you're working on, say, the recipe and the robot recipe editor, there would be, oh, by the way, here's a button to look at, for example, substitution for this ingredient, or food recall for this ingredient, or whatever. So improve the local map so it's aware of stuff coming from, of stuff in the K-Hub coming from other applications. improve the unification UX so it's better because we won't get it right the first time. These are work items, they're not components. Experiments with NLP unification and unification validation by human. And then long-term federated query, epistemic federation, global concept identifiers, so we can have federated queries and canonicalization. And that's the blue sky. But that is not, you don't need that blue sky to deliver something to your organization. But this is something you can say, that's the blue sky.
I don't know if you're tired, but I'd like to understand the long term. I don't know if I'm allowed now to ask any more questions, but
yeah. No, listen, this is the point of this.
Okay, because I'd like to understand everything that is on this slide, but if you I think just one or two, I'd be happy already.
No.
To understand where your end goal, I think it would help.
No, I understand. Okay, so key hubs correspond to communities and sometimes sub-communities, but I mean, this is me being, I don't believe people will adopt a centralized system. It's true that Wikipedia made it, but there's even a fork of Wikipedia, which is Conservapedia, for obvious reasons. They needed Wikipedia for falsehoods, I guess. I guess some half-truths. Anyway, I'm just being nasty here. But I don't expect people to agree on one application to rule them all, unlike Tim. But hey, if we succeed, it's great. But I don't expect it. So what I'm expecting.
Sorry, you don't expect them to agree on one what?
I don't expect all humans to accept a single computer system as a point of reference, a single web app or a single thing as a common point of reference.
The abstract model topic maps, isn't that common?
No, it's not about accepting the same abstract. It's not about whether they'll accept the same abstract model. It's whether they'll accept the same content populating that abstract model, because people disagree. This is about difference of viewpoint. And I did say key hubs correspond to a community with a more or less, and maybe there's sub-community, but there's a more or less common viewpoint in the key hub. And here I'm saying, okay, what happens when the viewpoints are not common? Of course, we could try to capture all viewpoints in one big web app. I don't expect that to happen. I expect people will try to detach themselves as soon as it happens. I may be wrong. Maybe it's possible. Like Wikipedia has managed it. Wonderful. But I don't want to depend on that crazy plan succeeding. I want to be able to succeed at helping people talk across viewpoints, even if they don't agree on a single application showing that multiplicity of viewpoints. So what I'm saying is, when you're on the Knowledge Hub showing this is what people around me believe, or this is what people around me think about, and hopefully with more or less shared epistemic status, you can do a federated query and say, okay, let's ask all the other knowledge hubs, what do you think about this? And get, these are the other knowledge hubs that have thought about this. And so that would be cached somehow. I'm thinking about using Bloom filters. That's a technicality. But saying which knowledge hubs have a lot of thoughts about this or different thoughts about this, and ask them, okay, what is it? Is there reasons you have to believe this or not believe this, and what are they? But that requires the concepts using more or less the same identifiers, because otherwise we're making approximation using the term, and maybe they don't mean the same thing by the same term. So hopefully you want to be able to say, if I'm making the distinction locally, this term could mean this or it could mean that. And then this other one, well, that didn't make that distinction, which is possible. Well, which one did it mean? So what you want to say is to say, well, here is my database row ID for this version and my database row ID for this version. let's agree on a name for both of these, a global identifier as opposed to a local row ID. And I want to know which of those two are you using in your K-hub, so that when I make the query according to one or the other, I know which one you're talking about. So this is about the K-hubs negotiating identifiers for different versions of a concept. And again, that doesn't mean that they agree on what it means. It just means that they agree on how to name it. And this doesn't have to be human readable even. This is just about having a way to go between systems and say, this is what I mean by these words, and this is what you mean by these words, and having identifier for different distinctions. And that, getting those identifiers to get unified in the long term allows canonicalization, which is Tim's goal of canonical. Each claim has a canonical identifier. Well, that's only possible if the underlying concepts have a global identifier, which I think can be done by contagion between systems. And then you can have canonical identifiers, which makes federated queries more efficient. Other sub-goal, the other difficulty is poisoning the well of saying those concepts are the same when they're not the same. Canonical example, when Mitch McConnell says that universal healthcare is socialism. It's saying that this is a kind of that, but it's a spurious, spurious concept unification. Like any social service is socialism? No. So you need to have reputation for unification. Is this unification generalizing too much and make it hard to converse? Again, whether you agree or not with, do you think universal healthcare is good or not? That's not the point. The point is, are you making different concepts identical, which makes discussion more difficult? Are you either erasing or asserting a useful distinction? And that's what I call unification reputation. And
you have an intuition on how you can identify and classify between good and bad?
See, the point, what I'm trying to detach here, the epistemic reputation, I think Mitch McConnell is lying about certain things. That's epistemic reputation, but that's not, but I'm detaching this from unification reputation, which is saying when you conflate concepts that somebody else think is distinct, and that distinction is useful in actual arguments, then this conflation is deleterious to having certain arguments. And that's independently bad.
Discussions will happen in the future, so maybe something that is useless now could become
entirely possible, and then we'll adjust this later. It's okay. It can be a live score. I don't care. But the notion is, if you're conflating things that are useful distinction in certain conversations, that is known to be bad, because we already know that this is a useful distinction in certain contexts. So you should not put these things together without saying, here I'm using an abstraction over those two, which is possible, which is valid. But if you're saying, no, they're exactly the same, that is the pollution I want to denounce.
But what is useful can change over time. I mean, one thing
yes, new distinctions can be introduced later. That's fine. I don't want
no, but also things, a big part of our minds evolving is us stopping to make the same distinctions. Is we used to think that the ether was something and to distinguish it from everything that was on the ether, and then we realized, no, that's really dumb. And stop making that distinction. And it was really hard, because the people who saw that it was stupid and who saw that it was fake use, we were producing something that looked like it was useful, but it was not. And that was really hard to undo.
Absolutely great example. And this is where what I would do in that case, like the distinction was useful for certain distinction, but it happens that one of the branches of the distinction has no, it was refuted, has no epistemic value. The questions got unasked, but the non-ether branch is intact, and you can go on that way. Another case is where distinction is made. Let me get another example. For sometimes it was thought that axolotl and was a species separate from in and of itself and not related to salamanders. And then it was discovered later that the axolotl was actually the neotenic larval phase of already known and separately identified salamander. So that salamander species and axolotl were found to be the same after the fact. So that distinction got erased by later knowledge, right? That's another example.
No, but that one is a very different example. That was not a problem in itself. It didn't stop.
No,
this wasn't like some. We just had to go one step before. But the problem with the ether is that, or even with the speed of light, you know, there's some point you're so convinced that the speed of light can't be a constant. It never hit you that you don't have the distinction. You're just like making so many other distinctions that you don't make the distinction constant or not constant. You don't have that in your head, and so you're so far ahead that when somebody that really looks like dummy say, well, maybe it is a constant. It's like, you're daft. Go back to school, guy. Do some physics, and you'll know it's not possible. And so the fact that you are, and this person would, it seems like what you're telling me is this person would be categorized as something that would annihilate all this effort in one direction to find out what makes the speed of light not vary.
The notion of reputation, I see what you're saying, and you're right, there's a danger there. But I think the notion of reputation is, we have to think it a bit flexibly. It's not about saying you're wrong, you cannot be right, and we'll just erase you from the conversation. It's about saying, you probably know the saying in English, extraordinary claims require extraordinary proof. If you're going to contest that, you better have some damn good evidence. Now, in this case, it turns out the evidence came later, but it was provided, and the theory behind it was provided. And, you know, it was, and yeah, it required.
I really disagree with that claim. Because sometimes some things are so simple and people have so overcomplicated things, just like with the speed of light, that a simple truth, like, well, maybe it is constant, it's buried underneath so much theorization that it seems extraordinary, too extraordinary, that people don't realize that they actually didn't consider it enough. So it seems like they did, because they are so far away further down the line. But this particular like simple suggestion, maybe it is constant. Yeah, so I don't think that would need more explanation. It needs to unravel, and this is so hard to do. So that if you make it more complicated for the person to unravel, this goes back to the example I gave in my case in my community. This review that made it, they tied everything so well together. It looked like they had the whole model of the whole community and of all the work we were doing, and everything was settled. And to unravel it, I mean, to go back in time, you have to know so many things. It's so exhausting, because you have to understand everything that is done in your community, and all the science, all the history of that community, both human and non-human, and mathematical and scientific, to understand how did you get to this point, to do then some reverse engineering of the scientific reasoning people are doing, and then to try and go back in time step by step. It is so difficult to do, and this is the kind of thing that explained community can go on for 30 years missing one of the main questions that it would have asked 30 years before. And it seems very stupid when you ask it, and when at last you have some way to prove it was a good question, because maybe in my case it was because I proved several theorems, and people wondered how did I do this? Well, because they were looking for it for a long time, but it was just that little question they hadn't noticed. And in some cases, but it takes a lot of chance, a lot of luck, or so much brain power that I don't think anybody has that kind of brain power. You need a whole community to undo a community's work.
Well, that's Kuhn's observation, right? Often a new paradigm replaces another paradigm because the people who get useful results with the new paradigm outlive the people who stopped getting new results with the old paradigm, and they never really actually convince the old timers that the new paradigm is meaningful. They just get more results, and then people's attention
I got
shifts.
a lot of results, but it's still in the end, it's the war you have to lead as a scientist is so exhausting. Here I am, like I gave up.
That's a reality.
Do the MMM because I think I really believe there's a shorter way where you emphasize the logic and you see that when something has not, it's not because distinctions are being made, that if you can see, if you can.
I see the work I'm trying to do as helping the use case you're describing. And you may see risks because of the reputation aspect. For me, the reputation aspect is very much, it's because I'm worried about political issues and I'm worried about disinformation and I want to have, it's a different use case. I do think that being able to say, hey, this thing got contested and nobody found a good counter argument to that contestation yet. Make that visible. And for me, this is about helping the use case you're describing. Not there's this whole échafaudage, this whole structure of work that believes otherwise. That's not a counter argument. But saying, why couldn't this other thing be right? I think for me, making that more visible is totally about helping new ideas get some support. But I also have the opposite goal of not helping disinformation, which is always a danger when you're showing all the options. Because if you're doing a map of here's everything that different people believe about this, well, there's, a million possible false ideas for one true one, and you're just drown the truth. So there's this balance between helping the new idea emerge and make its place and saying this lie, well, it's easy to disprove.
So just for the first thing, so I agree with what you said, and I actually thought when I was building the MMM and for my own research, I would have loved a system like the MMM that could have been able to show, okay, this question, either it's never been asked, if it's never been asked, that's enough to just study it in itself, and it's not because there is nothing, it's just there's so much. The fact that there is so much things that presume the answer is actually in itself a reason to go answer this first question, because everything seems to rely on the answer. So maybe we should actually answer it. So in that sense, and then so these two kind of use cases, you see is it like there's a continuum? Is it for different applications completely? Like for scientists, you would remove totally this.
No, I think even for scientists, it's useful to know, this has been explored in the past and it's been disproved this way. And maybe you can say, you know what, this disproof is not good enough. And here's why I think this disproof doesn't hold. And let me disprove the disproof or contest the disproof. And that's valid. You can also go back in time in the sense, not necessarily saying, this disproof doesn't hold water in view of this new thing. And then if you're talking nonsense, because some scientists are talking nonsense, it happens, then people can say, well, here is why your counter disproof doesn't hold water. And, it gets what I found in the public conversations around climate change is that very often you get people saying, of course, climate change exists. Then you get the denier with an argument. Oh, this is why climate change is a hoax. And if you look at the argument, it's actually, if you're not an expert, sensible enough. And then you go to these climate change sites that do the work of saying, well, okay, it looks sensible, but here is why it's wrong, and blah, blah, blah. And I've never seen, and sometimes there's people who will put this argument, and those never get contested. It's very rare that the climate change deniers will go one level beyond and refute the refutation. They don't, because they can't. But also they could make up a new line, but they don't bother. It's enough for them to repeat the already refuted argument often enough in enough different conversations or in the same conversation with newcomers to sow doubt. And that's all they care about, really. So they don't bother refuting the refutation.
And this is something I expect that can be exploited, because just in the way you describe this, you can see there's a different kind of pattern to the different kind of proofs. One of them doesn't look like a proof, the other one could. And if they try to make it look like a proof, maybe they actually are going to end up smarter, or they're going to hit the rock bottom and realize that the axioms are stupid. So this is I'm not sure you need reputation, and I think that you can do without it by just actually going and seeing why they're doing. It's not because they are saying silly things and they are silly people. It's just because on this particular case, the reasoning doesn't work, or there's nothing to it.
Well, on the one hand, I agree. On the other hand, sometimes the arguments why they're wrong require a lot of background knowledge that non-scientists find hard to follow. And again, that's how they get following. So that's one problem. But here, I really want to insist on the distinction between epistemic reputation, which is a very hard problem, which I'm not sure I can solve, and the much simpler unification reputation. Because I'm saying erasing distinction is a very special case, or perfectly spurious distinction is a very special case, which is much easier to detect, very harmful to the system, but very easy to detect. It's very easy to say here people are are conflating two ideas that are actually distinct, and we can know that this is toxic to the nature of the debate. And it's an important enough case to distinguish, and because it can be distinguished reliably, it's not maybe you're right, maybe you're not, you need more expert knowledge to know.
Put a target on to put a label on somebody. Why wouldn't you just label the link? For instance, if somebody made the link, like said something equivalent to something, why don't you just like, because if you know that it's not a good link, then you have reasons that can that can be exhibited. So that means that there's another path that links these two ideas, and that is evidence that they are different. So you should have two paths, and then you don't need the person, you just need the information.
Okay. The reason I want to have reputation is, don't forget, I'm thinking of a mix of humans and agents here. And if we're speaking about agents, I absolutely want to say this agent is not so reliable. And this is a generic agent level reputation. Now, I agree, in most cases, you'll be able to say this link is spurious, but maybe this person is very reliable in this domain and not in that domain, which is another refinement, which I totally believe is necessary. This person understands this domain very well, but is making perfectly ridiculous statements in another domain consistently, or not, or maybe just once, and maybe they'll correct, and that's fine. Or, there's all kinds of sub cases we could get into. I'm just giving here a box saying we need to be able to judge whether a given unification is believable. And we'll need many mechanisms for that.
Okay, that's something I need to mention here. Although you told me epistemic federation, I mean it's a very long-term goal, but
epistemic federation is much simpler than epistemic reputation. It's about saying, how do I represent well, and this is a UX problem. This community thinks this is a base truth. This other community thinks this is a open research question. This other community believes it's unbelievable. I want to give a kind of good synthetic view of, okay, this is what we find overall. How solidly is this being contested? What is the quality of the arguments? But not in the we judge truth, but just in the we judge how many people believe in this. Hi, Tim.
Okay, so now the remark I wanted to make was that I need to make here is I think we need a very big distinction, a very clear distinction between when we talk about science when it's just communicated and science when it's being made. Because when you're making science, you're going to say it's the whole point is of you're going to say a lot of things that are not true. It's science. 99% of science is not true, and it's not about you saying something being better in some domain than another. Is that the domain in which you're the best is the one where you're sorry, I'm disturbed by this noise.
Oh, sorry, I was typing. Oh, no, let me silence myself. Well, just Tim, for the record, this is recorded, may get public, so we're avoiding talking about Mathilde's specific project.
Got it.
Go on.
So you can't have a reputation for scientists. It's very scary for me, the idea of having a reputation for scientists, because some scientists are really good at, there are so many roles, and some of them are, you're saying things slightly wrong because you're the kind of person who understands things at a very high level, abstract level, and the way you put things into words is never quite how you should put it. But somehow there are a certain kind of people who manage to make gold out of your slightly nonsense, slightly accurate. The way somebody can talk, we don't care if it's true or not. That's not the point. It's you measure it by if there is some person on earth who can make gold out of it, and that you can't really decide this in advance. And I would be terrified if we started getting reputation because we're scientists. It would, for me, it would be the death of science. It would be really risky.
I think I understand what you're saying. It makes sense to me. I'm not saying I have a full answer to that. I think reputation is important in the system overall, but what I would tend to do for that use case is very much keep the internals within knowledge hubs and not in the public federation, or maybe have sub-federations, so that you could say, we're dealing within this federation and in a certain way, and we don't have this kind of reputation, and then there's what we publish, which is another layer to the public federation. I think that's possible. There's nothing stopping the federation from being fractal, but yeah. So Tim, you come at the end. This is the grand hyper-knowledge vision. I try to say, what are the, and you have the link in the Hangout chat, the link to the presentation, and what are the short-term, which would give an MVP up to a point, very simple, midterm continuous improvement, and long-term, that's the grand hyper-knowledge vision, and the grand canonical debate lab vision, but it's not needed for Mathilde's project at first. So I tried to break things down, but first I went through, okay, these are the pieces. That's what we went through.